Launch vehicle, commonly called as rocket, is used to carry satellite or spacecraft to outer space. It has payload system and propulsion system. These systems are held together by airframe. Let us go in detail through parting it further. Starting with nose. It is a streamlined body that can easily pass through air. It holds the payload such as satellite or spacecraft. Payload adapter that connects payload to rocket's airframe. Instruments required for rocket's functioning. These all covered by the structure called fairing. Coming to the propulsion system, starting with the lower stage, it consists of liquid rocket engine and solid rocket booster that operates in parallel. So this can also be called as parallel staging. Liquid rocket engine. It consists of fuel tank, oxidizer tank and thrust chamber. In order to start the rocket, both fuel tank and oxidizer tank should be connected to thrust chamber. Here, the fuel and the oxidizer should be fed in a desired rate to the thrust chamber. This can be achieved by placing the pump, one for fuel line and the other for oxidizer line. To control the flow, valves are placed in both the lines. But how do we operate the pump as there is no such powering device? So we create one. The gas generator. This extracts small amount of fuel and oxidizer from main line. It is mixed and subjected to combustion. The hot gas produced is streamed towards the hot gas turbine that is connected to a gear that which drives another gear. The driven gear is connected to both the pumps. As turbine rotates, the gear rotates the pump, enabling the flow of fuel and oxidizer into thrust chamber. As turbine rotates at very high speed, the speed has to be reduced to operate the pumps. This is achieved by the reduction gear assembly. Once the flow in a line is established, it is allowed to pass through the injector. Later, fuel and oxidizer gets mixed and undergoes combustion. The high pressure product is later converted to high velocity jet. The common arrangement of tank is as following. Tandem tanks. Here the tanks are arranged one after the other and the piping is done externally. Spherical tanks can also be used in tandem but for smaller system. Tandem tanks with common partition can also be used. In some case, the fuel tank is arranged in concentric with oxidizer tank. Even the multiple tanks can also be employed based on requirement. The arrangement of oxidizer tank and the fuel tank can be seen here. Coming back to the thrust chamber, it involves combustion chamber and the nozzle. Here, the oxidizer and fuel is combusted inside combustion chamber. Later, the combusted product is expelled out of nozzle as the jet. As a reaction, the forward thrust is generated. What exactly happens inside the combustion chamber? It has an injector with many tiny holes. These holes are connected with oxidizer and fuel manifolds. As the fuel and oxidizer passes through these holes, they get atomized and vaporized. This zone is called as vaporization zone. Moving forward, vapors gets mixed in mixing zone. After mixed finally, it reaches certain point where the mixture undergoes combustion, forming combustion zone. This leads to high pressure products. The combustion chamber is connected to nozzle. The nozzle has converging and the diverging section, hence called as converging diverging nozzle, or in short, the CD nozzle. Now coming to the nozzle, it has converging section that is directly connected to combustion chamber, which holds high pressure gas at subsonic speed. The gas is accelerated in this section to reach the sonic speed. once reaching the sonic speed, the diverging section should be employed to accelerate it further to supersonic speed such that the high-speed jet can provide enough thrust for rockets lift off. As high-pressure gas expands to form high-velocity jet, if the jet exits the nozzle at pressure greater than the ambient pressure, the resulting jet plume is diverged, where some of the thrust generated is wasted. This is called underexpanded nozzle. If the jet's pressure is lesser than the surrounding pressure, the resulting jet plume is converged, where the thrust obtained is low. This is overexpanded nozzle, not efficient one. When the jet exit pressure matches the surrounding pressure, it results in jet plume which is straight, enabling more thrust in forward direction. This is an ideally expanded nozzle and designed for good liftoff. In reality, sharp edges are not suitable for high-speed flow, which may result in shock waves that may block the nozzle. So, the converging nozzle will curve gently into the throat. Then, the curve will turn into a diverging one, allowing smooth transitioning to the cone, resulting in curve-shaped nozzle. As lower stage of the rocket also has solid rocket booster which is connected to the frame of liquid rocket engine by the means of explosive bolts. Once the SRBs run out of propellant, they can be detached. What do the solid rockets hold? It has casing that covers the propellant grain and the igniter plug. Igniter plug enables the ignition, causing the burning of propellant grain, which results in jet of hot gas moving out of nozzle, creating the thrust force. The cut section of solid rocket looks like this. As propellant burns, the burning tube size increases, resulting in larger area over the time and more thrust. Once the propellant is emptied, solid rockets are detached. After the completion of lower stage, we will head on to the upper stage or stage 2. Here, the lower stage and upper stage is connected by the means of structure called interstage. Interstage also connects the nose to other stage. Upper stage basically holds the liquid rocket engine and the working is same as previously mentioned, but it's operational in higher altitude and is a part of series staging. As the airframe holds the engine, to control the rocket direction, the nozzle should be made able to move in desired direction. This can be achieved by providing support structure that connects the pivotable thrust chamber to airframe. The retraction and extension of actuator makes the thrust chamber to move left or right, forward or backward. This is called gimbal thrust direction control. The designed parts are later integrated to one single launch vehicle or rocket which is all set to be launched.